Hi children, how are you? I hope all are fine. Today we discuss about motion. Generally, we have seen many examples of motion around us, like motion of people, motion of vehicles, motion of trains, aeroplanes, object thrown into air. Do you know what causes the phenomena of sunrise, sunset and changes of seasons? If Earth is in motion, why do not we directly identify the motion? Why? To give these answers, to these questions, we need to understand relative and motion. What is relative? Relative. What is relative? We use many statements in our daily life to express our views. The meaning of statement depends on the relation between words used in it. We write some words. This circular is plate gaseous. Use these words, we construct two statements. First statement is this plate is gaseous. Second statement, this plate is circular. This plate is circular. Statement 1 is this plate is gaseous. Second statement is this plate is circular. So observe these two statements. First statement. This plate is gaseous. This plate is gaseous. Has no proper meaning. So observe the second statement. This plate is circular. So second statement has a perfect meaning. Because in this first statement, plate and gaseous words are not relative. In second statement, plate and circular are relative words. Plate and circular is relative. The statement has meaning only when there is a relation between words. Let us learn about relation with respect to the position. These two typical sets of positions, they are right and left, up and down. Real life examples, day and night. Now we discussed right and left. Right and left. For example, we construct that two persons. persons. There is a one. Two persons A and B are move opposite direction to each other. There is one house. For the person A, this is person A and B. For the person A, the house is on the left side of the road. Person B. For the person B, the house is right side of the road. Thus the position of the house is relative to the observer. That clearly, when speaking the left and right of a person. The position of the house is related to the person. That clearly, when speaking of the left and right of a person. Next we discussed up and down. Up and down. For example, we consider a ball. One ball. Ball in spherical shape and fixed 4 pins. On both four sides of the ball. Name them P, Q, R, S. In P point of view, the position of the pin appears up. And the position of the pin Q appears down. But point of view, this is but in the view of pin Q, it appears exactly opposite the same way. The direction of up and down are not the same for the pins R and S. They change with the position from where the pins are observed. We know that Earth is sphere. The upward direction of the vertical position on its surface depends upon the place on the Earth's surface. That is the place where the vertical is drawn. Hence the notation up and down have no meaning unless the point on the Earth's surface to which their refers is defined. Next we see real life example. So real life examples mean day and night. Here day, night. Day and night. Here the question, is it day or night? The question, is it day or night? The question, is it day or night, cannot be answered without indicating the point on the earth. So this is A. A is the day, B is the night. Consider the points on the earth surface A, B. In a way that A is in the day, A is in the day part, and B is in the night part. For the same question, the person at A says it is a day. A says it is a day, and the person B says it is night. It is night. The simple fact is that day and night relative notations. And the question cannot be answered without indicating the point on the globe where the question is being asked. Next, to understand the idea of motion, let us take the following hypothetical activity. That is the page number in your textbooks. Page number 3. The conversation between Seenu and Somesh, who stand beside the road. See this picture. So both are conversation. Seenu says, what is the state of motion of the tree? What is the state of motion of the tree? Somesh says, is it at rest? Somesh says, it is at rest. Seenu, what is the state of motion of the car? What is the state of motion of the car? Somesh says, it is moving due east. Next one, Seenu, what is the state of motion of the driver and the passenger in the car? What is the state of motion of the driver and the passenger in the car? Somesh said, they are also moving like the car. Next, Seenu, how do you decide that the car, the passenger and the driver are moving? Somesh, With respect to us, the position of the car, the passenger and the driver are changing with time. So, they are in motion. They are in motion. Next, conversation of the driver and passenger in moving car. Driver says, what is the state of motion of the tree? Passenger says, it is moving to west. Moving to west. Driver, what is the state of motion of the both the persons beside the road? Passenger, they are also moving due west. Driver, what is my state of motion? What is my state of motion? Passenger, you are at rest. You are at rest. From the discussion, it is clear that motion of an object depends on the observer. Motion of an object depends on the observer. So, motion is a combined property of observer and the body which is being observed. So, what is the definition of motion? What is the definition of motion? A body is said to be in motion when its position changes with respect to time. Respect to time. A body is said to be in motion when its position is changing continuously with the time related to an observer. Okay, next we understand another examples of motion. Another example of motion. A man standing at point O. A man standing at point O. So time 0 seconds. The time is 0 seconds. After 2 seconds, the man position is not changing. After 4 seconds, not change the position. Next, after 3 seconds, after 6 seconds, man's position does not change. Next, another man standing at point A. After 2 seconds, the person changes position B. After 4 seconds, the person position change at the point C. After 6 seconds, the person position changes point D. The point D. In the two situations, the body does not change its position. The body does not changes its position with time. With time. Next, another one. The body changes its position with time. With time. That means this is a rest position. The person is rest. The person is in motion. The person is in motion. So, what is rest and motion? Rest is a body does not change its position with time. With time. So, what is motion? Motion means body changes its position with time. Okay. So, what is motion? A body is said to be in a motion when its position is changing continuously with time related to an observer. Related to an observer. Now we discuss distance and displacement. Distance and displacement. There is a car moving on the path. There is a car moving on the path. There is a car moving on the path. The initial point is A. Car move on the point A, and finally it reaches point E. Point E. So distance A to B. A to B distance is 2 meters. 2 meters. B to C 4 meters. B to C 4 meters. And C to D 3 meters. D to E 2 meters. Finally, A to E distance is 7 meters. A to E distance is 7 meters. What is the distance travelled by the car? What is the distance travelled by the car? Distance from A to E. Distance from A to E is equal A to B plus B to C plus C D plus D. So AB length is 2 meters plus BC is 4 meters, CD is 3 meters, DE is 2 meters. How much? Add this 2 plus 4, 6, 6 plus 3, 9, 9 plus 2, how much? 11. So 11 meters. 11 meters. So that means distance. So distance means total path covered by the car. Total path covered by the car. So what is the displacement? Displacement is car displaced A to E. Car displaced A point to E point. So displacement is AE is equal, how much displacement? 7 meters. 7 meters. So distance is 11 meters. Displacement is 7 meters. So what is the displacement? Displacement is shortest distance. Shortest distance between A and E. Displacement is shortest distance between A and B or A to E. So what is the distance? So define the distance. Distance is the length of the path. Distance is the length of the path. Length of the path travelled by an object in a given time interval. So distance is the length of the path travelled by an object in a given time interval. So displacement. So now define the displacement. So what is the displacement? Displacement is the shortest. Displacement is shortest distance covered by the object in a specified direction. In a specified direction. Distance has no direction. Displacement only having the direction. So describe a physical situation, any situation. Some quantities are specified with magnitude. Magnitude means number. Magnitude means number. Magnitude as well as direction. Distance. Describe displacement is described to magnitude and direction. Magnitude and direction. So that is the vector. That is the vector. So displacement is vector. Displacement is vector. Next, distance. Next to quantity. The physical quantity which does not require any direction. Any direction for its specification. So it is called a scalar. So in this distance having the only magnitude, no direction. So that's why distance is the scalar. Distance is the scalar. So units of distance and displacement. Both are measured in the same units. Distance and displacement is the same units. That means meters, centimeters. SI units is meters. CGS units is centimeters. Units is SI units is meters. CGS units is centimeters. Centimeters. Next, the difference between distance and displacement. So distance is the length of the path travelled by an object in a given time interval. Displacement is the shortest distance travelled by the object in a specified direction. So units of distance and displacement. SI units is meters. Displacement also SI units is meters. CGS units is centimeters. Displacement also same, centimeters. So distance is the scalar. Displacement is the vector quantity. Displacement is the vector quantity. So differentiate the scalar and vector. What is the scalar? What is the vector? Vector means physical quantities are specified with magnitude as well as direction. Magnitude and as well as direction. Scalar is the physical quantities are which do not require any direction. Which do not require any direction. Its specification is called the scalar. So examples of scalar. So examples of scalar and vector. So scalar examples is distance. Already we know that distance. Another one is time. Another one is time. Next mass, length, mass, length, etc. Mass, length, etc. Vector examples. Displacement. We know that displacement is a vector. Another one, velocity. Velocity. Next, acceleration, weight, acceleration, weight, force, etc. Force, etc. These are the vector and scalar examples. Okay children, once again we repeat important definitions. So what we learned in this section? Motion, rest, distance, displacement, scalar, vector. Yes or no? So once again repeat these definitions. So, motion. What is motion? A body is said to be in motion when its position is changing continuously with time relative to an observer. Okay. Next, rest. Rest. A body does not change its position with the time. With the time. Next definition is distance. Distance. Distance is the length of the path travelled by an object in a given time interval. Okay. Next one is displacement. Displacement is the shortest distance covered by an object in a specified direction. Next, scalar and vector. So what is scalar and vector? Vector means describe a physical situation. Some quantities are specified with magnitude as well as direction. That is the vector. It is the vector. The physical quantity which does not require any direction for its specification is called scalar. Okay, now children? Next, leave the home assignment. For you, home assignment. First one. Difference between distance and displacement. Distance and displacement. Next, difference between distance and displacement. Next, second question. Define motion and rest. Define motion and rest. Define motion and rest. Another question. Write examples of scalar and vector quantities. Write the examples of scalar and vector quantities. Next question is fourth one. Write daily life examples. Write daily life examples of motion and motion. Next question. What is relative? What is relative? Once again I repeat the questions. First one. Difference between distance and displacement. Define motion and rest. Write examples of scalar and vector quantities. Write daily life examples of motion and rest. What is relative? Okay, na children? Next. Okay, children, read your textbook and write answers for these questions. Okay, children, thank you.